Beautiful day, guys, huh? Beautiful day so far?
Mm-hmm.
Uh, I feel the energy by Samantha. You're having a great day so far, it seems, Samantha, huh?
No, actually, I'm sick.
Oh, what has happened? Sorry to hear that.
I have allergics. I have allergic to multiple things, but I don't know. And my throat just swollen up, and I can't swallow my own saliva. I feel so hurt when I'm doing it.
Oh, sorry to hear that.
Yeah, when I take the medicine, it make me feel like sleepy.
Oh my God, I'm sorry to hear that. I hope that you, after I should say taking 2 hours of advanced function, you feel great.
Oh, okay,
I
that's
think
prescription from doctor.
that's it. But I hope that after 2 hours of the advanced function, it makes you feel great, and you have no sore throat or something like that. You feel
Mm-hmm.
as good as before.
Yeah, I will.
Yeah, awesome. Hi, Mingji, how are you?
Good, good.
Good. Great day so far?
Yeah,
Awesome. Good morning, Linda. How are you?
Fine.
Have you done homework?
What?
Huh? Beautiful day so far?
Yes.
Ah, you sleepy a little, huh? Yeah. Good morning, Sean.
Good morning.
How are you?
I'm doing pretty.
You're what?
I'm doing pretty.
Oh, I'm so glad to hear it. That's a good
Isn't that
energy.
beautiful today?
Isn't? Oh, it's beautiful, awesome out there.
So glad to
Awesome.
hear it.
That's right. I'm
Yes.
so glad to share the same, I should say, feeling about the day today. Thanks, man. Thanks.
No problem.
Good morning, Oliver. How are you?
Hi, good.
Awesome. Beautiful day.
Yes.
Oh, glad to hear it. Glad to hear it. Fantastic. Fantastic. Guys, I want to ask you one quick question. Not all of you submitted your homework. What's happening there? Everything is fine?
Yeah.
Yeah. And some of you did the wrong homework. The homework which I mentioned that you please do that. I submitted the PDF format. This is called logarithmic functions into the main site, the main page. And from that, which is I think 9 pages, I didn't mean the homework from the book. I meant the homework from that, I should say, PDF document. Then if you haven't done that, please check back again to that document because it contains very rigorous exercises for the properties of the logarithm. And Minjay, thank you very much for being on time and finishing this, and also you, Samantha, and everyone, that I'm sure that you did a great job on that thing then. Guys, before we move on today, I had 2 questions, one from Samantha and one from Sean, which I'm just going to finish with them right now. Then we move on to continue with the logarithms. Then we finish some part of the logarithms. And by Friday, hopefully, we should deal with the logarithmic equations and inequalities. Then today we are going to be a little bit fast. Before I start, I just wanted to tell you that the recordings which I make with these lessons, some of them, the size exceeds the size which the Schoology has, I should say, the capacity to upload. Then I cannot upload them onto the Schoology. I upload the ones which I cannot. I upload them onto the YouTube. I provided you the link to the YouTube. In case if you want to review that, just please click on the announcement which I make, follow the link, and you will see the recorded lecture. Clear, guys?
Clear.
Yes, everyone?
Yes.
Ah. Samantha, I think that maybe I should say, oh, by the way, Sean is gonna play us a nice music on Friday. Huh?
No.
Yes,
no.
Friday, guys. We have a good surprise for Friday. We have
And Samantha will sing the nice song in the
maybe she's a little.
Don't drag me into this. Oh my god, I just want to stay out of this.
No, why you always refuse to sing the song?
No, you can sing the song.
Is there any problems to you?
No, I mean,
No,
yes. Yes, sorry. Don't drag me into this. Oh my god.
Okay.
Please start, Mr.
Maybe
Obi.
Sean.
I do believe you have the great talent in singing.
Oh, thank you. You admire me, but I'm seriously.
Yeah, I admire you a lot. Oh,
Oh, okay. I admire you the
I
talent of
appreciate that.
playing music. Playing now, okay? As a background music.
I just wake up at 8:56, so I'm sleeping now.
I wake up at 8:50, and then I just log into this Zoom
That's
and
so
wait
true.
until it starts class. And then
I do not
class starts.
even wash my face.
Oh my God, that was so funny. Guys, yeah, but anyhow, let's fight over that once more during the break time. Now let's finish this. But guys, the surprise, which I said that on Friday, the first surprise is that Sean is gonna play music, and also another surprise is that we're gonna be done by the logarithmic functions. And if you are loving this topic too much, then Friday, the joy is gonna be over. We're gonna start something new then after that. Okay, this is a question which I should say Samantha asked. Everybody sees this question. Still, I'm sorry if the quality of broadcasting this stuff is horrible. I'm so sorry, guys. I'm still working on it. Everyone can see this function?
Yep.
How about the rest? Mingji, Oliver.
Yes, guys.
Mingji, Oliver, Linda.
I can see it.
You can see that?
Yeah.
Awesome, awesome. Okay, guys, anybody try this one when you were doing your homework? Yes? Guys.
Oh.
How
This
beautiful
question.
does it look? It looks like a flower.
Is that Samantha's question?
That's right.
Oh, okay.
Anybody try this?
We can try it now.
Yeah, please give it a try. For 1 minute, at least come up with a strategy how to deal with it. Samantha, did you think of that when after that, you know how to deal with it?
Well, I have a clue. Like, I'm not really sure about this, but I do have a little clue. Just hold on a second.
Can you, Samantha, can you please, while you're thinking of a strategy, can you please plot this on Desmos?
Yes.
This function looks so beautiful, guys. It looks like the flower. Oh. It takes so much time even to plot this, to put the figures. Guys, did anybody solve this? Mingjae,
Yeah.
did you solve it?
I'm solving it.
Oh, nice. Oliver?
Yes.
Are you working on it?
Yes.
Awesome. Awesome. Linda,
Yes.
are you working on it?
Yes.
Ah, nice. Sean?
Uh,
Oh, it was so funny that you said
oh,
that you woke
I'm
up.
going to go to the washroom to wash my face.
Sure.
Okay, 1 minute.
Linda, did you Samantha, did you plot it? Samantha,
Yes.
are you done plotting it?
No, actually, it takes me a while.
That's so
Just
true
hold
because
on
there
for
are
a
lots
second.
of screwed brackets entangled. Guys, but no worries. While Samantha is doing this, I'm going to give you the clue. What is the key strategy to deal with this kind of entangled functions? Because you can see that this function is this f of x. Oh my God, I forgot to, my markers is all dry. I forgot to, oh my goodness, I have to buy them again.
Wait. I have a problem. Do you mind if I share my screen with you?
Just keep your, just plotting for temporarily couple of minutes, I should say, on hold, because I just wanted, the point which I wanted to make is that how simplifying this one is gonna help you for even easier way to plot a function. Please put that on hold for a second, and let's deal with the function first. Okay, Samantha, because the whole plan was that to make sure that, oh, you feel problem when you even want to plot it on Desmos. It was not easy, Samantha, huh?
Yeah,
Yeah.
and it has problem like I can't like really typing like cube square square root of something.
Uh-huh.
Like in the denominator, I should type is cube square root of x squared, but
Uh-huh.
on Desmo I can't actually doing it.
No worries. We do that in the break time. Okay, you don't mind?
Okay.
Awesome. Thanks. Let's guys, sometimes you do not have enough Desmos, then you want to see what these functions behaves. What's the best strategy to do that? When you see, for example, how many square roots you see, 1, 2, 3, and all of them are entangled. The first thing is that, guys, the best thing that you can do, even if you have this on the test, when you have these kind of things on the test, we also covered that yesterday. We said that if you have, and for example, x, and your x goes to the power, for example, n over m, right? Then essentially it becomes what? It becomes the square root of, you have your x. You noticed yesterday that the n falls down. You see, guys, what I'm writing? Or no, the window is not well positioned. Everyone see what I write? Yes? Becomes x to the power n, and falls down on the x, and m remains there.
Mhm.
M remains here. Do you see that, guys?
Yes.
Is it clear? I'm gonna do the same thing, exactly the same thing here with the same function which I have. But contrary to the thing which you saw yesterday, when we were working on the logarithmic function, we were trying to work out from the greater scales, the bigger scales, narrow it down to small logarithm functions. But for this one, it's different. We start from inside to try to work from small details, then moving outwards to just deal with the bigger functions, huh? The thing which I'm gonna do, the strategy, guys, is that then I'm gonna use this identity, which I know in algebra, to just work with this function. What do I mean? I mean that when I start from smaller scale, what is the first squared roots which I see in the smaller scale. It's this one, huh? You see that? Okay, in that case, what do you think, guys, the square root of the x should be? Should be x to the power of what?
1/2.
That's right, 1/2. Is it clear for you all? Linda, are you fine with it?
Yes.
Yes? Everyone is okay with this, huh?
Yeah.
Awesome. Then when I just want to do this one, I just read my function like that. I say f of x equals to, I'm going to write my first, the bigger I should say, square bracket first. It's the power 3. This one. The first item which I have there is x to the power what? 1/3. Anyone see that?
Yeah.
The other one which I got is what? Is x
Oh,
to the
power to 1/2.
1/2. And how
Denominator.
about the one at the denominator?
I'm sorry. Is x to the power of 2/3.
That's so true. The one at the denominator. You have the x, and the power is going to be what, guys? You see, the one which you have on the head of the main function, because of this identity which you learned, goes to numerator, and the one which is here goes to denominator. Yes, guys?
Yes.
Awesome. Then what's remaining now? The thing which remains now is you have to make them simplified. And how to do that? You remember from your previous courses that if you have, for example, let me write it with a different color. I'm going to write it here as, let me put this inside. I forgot to just put the markers back. It's all getting dry. The thing, guys, that we learned was that we say that if the base is going to be the same, n times a, the base is going to be m. You see, when the base is the same, you learn it, you keep the base and you added the exponents. Do you remember this, guys? Yes? Then if you remember this, it becomes very easy because you see that you have the same base, but the exponents are different. Then what do? You come here. Let me write it here. You keep the same base. And what is the result if you add 1/3 plus 1/2?
One over the 3
Plus 1/2. It's
is
very easy.
6/6，5/6。
5/6. Correct. Everyone is fine that y is 5/6. How about this one? It is going to be 3x with the power 2/3. Correct?
Yeah.
Then still, I'm working with this one. Look at that. I have x to the power 5/6, and I have x to the power 2/3. Huh?
Mm-hmm.
Okay. What's going to happen now? I'm going to simplify this one further.
Is that a factor minus denominator?
That's right. And what I'm going to do, guys, you remember this. I'm just going to write I'm going to write it here. I'm going to make a square here in order to show that identity, which I'm going to use right now. You remember that from the past, that if you have, for example, 1 over any base, which the base is the power of the n, equals to what? a minus n.
Mhm.
You remember this from the past, that if you take your function with an exponent from downstairs to upstairs, only you add one minus sign to the exponents, huh?
Mhm.
I'm gonna do the same thing here. I'm gonna come here and say, this one is still f of x, still equals to the square root of 3. I'm gonna have x to the power of what? 5/6 times x to the power of what? -2 divided by 3. I kept the one at the numerator up. I took the one at the denominator going up. Only I just added one minus there because of this identity. Everyone is clear with that so far?
Yep.
Yes? What's going to happen next? The same thing. I have the same base, but the numerators are, the exponents are different. What I'm going to do? I'm going to add the exponents. I keep x, and I put 5/6 minus 2/3. Everyone see that? Still, I have this 1/3. What is the result, guys? 5/6 minus 2/3.
Wait, what we're doing is like, you think is, I think it's minus minus. I think it's plus in the end because there is a minus. It's already -2/3 over there.
Where is the, you mean this
Oh
one?
no! I'm sorry. My bad. Sorry. No.
I
My bad.
simply kept the base. I added them together.
Yeah.
5 plus 6 minus 2/3 because based on
Yeah.
this identity.
Yeah. Sorry.
Huh? What is that going to be, guys? 5/6 minus 2/3. Linda, how much is that going to be?
1/6.
1/6?
Yeah.
Fantastic. Then it becomes what? As Linda said, it becomes, I have this one, I have my x, the root is 1/6, and I have this one to the exponent 3. Correct?
Yeah.
Guys, but there is one thing. I still, at the very last stage, I can still use this identity.
Mm-hmm.
You see? What do I mean? At the end, I can say it's equal to, keep the x. I know whatever is on the exponent of the x,
Mm-hmm.
it is supposed to be where? It is supposed to be where? At the numerator of this. Look at this one. Whatever is n comes to the numerator of this ratio of the exponents. You see that?
Mm-hmm.
n. My n is 1/6, correct? I put 1/6 here. What I'm left with now?
3.
3. 3 has to come where? This is like the m. M goes to the denominator. 3 comes here. That's correct?
Yeah.
Then I have 1/6 divided by 3 as an exponent to the x. Then what's the end result, guys? I have x. What is the exponent?
Just
How much is that? 1/6 divided by 3.
1/18.
That's right. It becomes 1/6 times 1/3. Yes, Samantha?
Yeah.
Becomes x with the power 1/18. Everyone sees this? Yeah?
Yeah.
X 1/18. And that's going to be the end result. You see, now we just starts from a very complicated looking, I should say, function, which is this. Let me put it back there. You see that we started from this horrible looking function. It's a breathtaking function. We simplify that to only to x to the power 118. And Samantha, which one is easier not to plot?
X over 118.
That's over 118. That's so true. Then you see when you simplify that, and guys, the only thing which I used continuously was this identity. X to the power of n over m is the square of x to the power n with the exponents of the m for the square brackets. Anybody has some problems? I review that one more. Anywhere that you got stuck? Linda? Linda,
Yes.
are you okay? Do you have any problems? Do you need some explanations?
No.
Are you sure?
Mm,
Linda, can you please take a look again to see if you have any problems? I explained to you more.
okay.
Yeah?
Yeah.
Oliver?
Yes.
Are you okay?
Yes.
No questions?
No.
Awesome. Sean?
Oh, yesterday I have a question. So,
Yeah, but are you fine with this?
yes.
Awesome. How about you, Mingji?
I'm fine.
Great. And Samantha, you're okay now?
Yeah, I'm good.
Awesome, awesome. Okay. And now, also, Sean has a question. We do the Sean questions. Sean, I think your question involves some inequality for the logarithm, huh?
Yep.
Yeah. We're going to cover that
After the okay.
Friday. We are going to have the lesson because if I do it now, the others gets confused.
Okay. No problem.
Okay. Is it okay when you're Friday when you give us a song? Then also I solve that one.
No.
Because Friday
Oh,
we're going to talk about the logarithmic functions. And I think that's the best time to solve your questions for everyone else. That's
okay.
fine?
No problem.
Awesome. Because if I solve it now, because the others, they do not have a background for it, they get, oh, what's happening there?
So
Okay, you don't
sure.
mind? Okay, Sean.
Okay.
Fantastic, fantastic. Then on Friday, we are listening to a song performed by Sean
And
and
okay.
Wait, I think I have another question, but maybe you can do it tomorrow morning.
yeah, please. Thanks.
Okay, yeah.
It's always
do
good
you want-
to, yeah, guys, please always, when you have some questions, let me know. We just do that during the class. The others also benefit to learn from your question. Yes,
Yeah,
guys?
I already sent into the group chat, so you can see it. So just in order to like continue teaching, maybe you can do tomorrow morning. I don't care, but I just wanted to, ask.
Thanks, thank you. Because I cannot see the chat right now because I have turned my laptop upside down.
Oh yeah,
And
right.
It
Yeah.
breaks my neck if I want to read something on the chat.
No problem. Just
Thanks.
go.
Okay. Now let's see. Okay, guys, let's move on. Okay, guys, now let's move on to do some exercises about the logarithms. But I'm going to do some 3 exercises. I hope that you learned, if you do the exercises, which it was your homework, those 6 properties of the logarithmic functions. If you are okay with these ones, now we are going to just work with some kind, I should say some extra stuff that some of the times we can just we have sequences of the logarithmic functions. We just want to make them in compact form. What do I mean? I just solved one example for you. I give you 2 examples to do that yourself. Then we just wrap up with the logarithms. We move on to the next stage. Look at that. For example, I just start with this one. I say, as an example, As an example, I say, for example, imagine this function. I say the log of 560 minus log of 7 minus log of 5. And everything is to the base, let's say, everything is at the base the 3. No, let's keep base 2. Sorry. I keep the base 2. Okay. The thing is that, guys, for example, it happens a lot that when you work in any industry, for example, you work in science, in physics, in, let's say, in economies, in finance, that you always end up after some numerical computations to some sequences of the log functions like that. But everyone can see this function, huh?
Mm-hmm.
That's right. Then when you end up with these kind of expressions in numerical analysis, maybe you're doing in engineering or in economies, you end up with some numerical computations like this. You ask yourself, okay, should I leave it there like that? Or you can end up to one unique number. If I ask you right now, guys, please everyone give me an answer. What is the answer? What number you can think is going to be the result of these log functions? For example, is it going to be 3, 10, when you calculate them?
2.
2? Okay, one answer 2. What else you guys you think?
No, wait. Just hold on a second. Is that a 560?
Minus log 7, minus log 5, all with the base 2. Okay, it is so hard to guess what is that, but I'm just going to use the properties which we learned yesterday to simplify that and compact it into one single number. Let's see what happens. And please, guys, you help me to let me know what are going to be the properties number, which I'm going to use for this one. I'm going to start with these ones. The first thing which I'm going to do, I'm going to write log 560 to the base 2 minus log 7 plus log 5. And these are the base 2. That's the first thing which I'm going to do, correct?
Mm-hmm.
Okay, after this one, after I'm done with this, the other thing which I'm going to do, what else is that? I see, oh my God, there are 2 logs with the same base. They are added together. What do you think? What's going to happen next?
So gonna be log 12 too? Like you adding up like the upper numbers together?
Okay. Samantha says that we add these 2 numbers together and it becomes 1 log. It means log of 7 plus 5, which is log of 12 with the same base, huh?
Mm-hmm.
Yes. What else do you think, guys? Is it correct? Can I just write that log of 12? Essentially, what Samantha says is that based on the properties which we learned yesterday, I can write this as log 7 plus 5, which is log of 12 with the base 2. Is it correct?
Yeah.
How about the others? Mingje?
I don't know. I have another way, which is log 2 560 divided by 7 first and minus log 2 and 5.
That's one approach. Oh, that's great. You started from that side. That's great. But how about this one? Can I just write log 7 plus log 5 with the base 2 as log 12 base 2?
I don't know.
Me too. Let's ask the others. I was kidding, I know, but I'm going to ask the others. Okay, Oliver, what do you think? Is it correct? I have log 7 plus log 5, and I check that I'm so lucky because when I check that, I see that these two bases are the same. When the bases are the same, it's such a relief because I can just keep the same base. And is it correct, Oliver, if I say I keep the same base and I add the main drivers of the log?
I don't think so.
Oh, you don't think so? Why?
I don't know, but I don't think you can just simply add them together.
Uh-huh. You're getting so close. That's a good progress. Thank you. How about you, Linda? Linda,
Yes, teacher.
can we do that? Can I say log 7 base 2, log 5 base 2, add them together, say log 12 with the base 2?
Give me 1 minute.
Sure. Essentially, I say this is, I have 7, I have 5, then I say, okay, I have log 12. Oh my God, I like when I use the colors. Oh, it's very relief. Guys, if you are wondering, check your notes from yesterday, please. And in the meantime, I'm going to drink some water. Linda, did you get any clue?
I see. Maybe no together.
Maybe what?
No together.
Sorry, say that again.
Together. Added together.
Added together, or you mean more added together like 5 plus 7, 12?
Yes.
You mean this is correct?
No, no, correct.
Not correct.
Yes.
How? What is wrong with it? Can you correct it if this is wrong?
Wrong.
This is wrong?
Yes.
Uh-huh. What is the correct one?
So difficult.
Sorry, what?
No, nothing.
Uh-huh. But that's a good thing that you say that this is not correct. That's great, Linda. Thank you. How about you, Sean?
Oh, I just eat my breakfast. Okay. Oh, the answer is 7.32. So log log 7 plus log 5 equals to log 35.
Ah, that's right.
5600 divided by 75 equals to
That's right.
7.32.
So true. Thanks. Thanks, everyone. Guys, look at that. It was a problem which I used to always make it after, I should say, even many years after the high school. When I added these together, I do not add these ones. You remember yesterday, Samantha, that we said that the log of, let's say, a function, as I said that, for example, log of, let's call that a, with the same base, I put it b, plus the log of, everyone can see that? B with the same base, for example, b small, becomes what? Becomes log of AB with the same base.
Oh, it's the multiply, right?
That's right. When they are added, that was the thing we talked about that yesterday. We said that, for example, AB are sitting at the same seats of the Lamborghini. They're fighting because they are multiplied. Then we give them individually a Lamborghini. Each driver has a Lamborghini by itself. Do you remember that example? And that's fine. Then as a result, when we have log 7 base 2, log 5 base 2, we do not add them together. Huh? We multiply them together. Then the correct way is what? The log of,
Log 35 too.
that's right, 35 2. Okay. And now, then it becomes very easier now. And what do I have now? I have the first term is going to be log 56, 560 base 2. Now minus log 35 base 2. Correct? What is the end result now? I have something opposite. I
Is
see.
divided.
That's so true. I say what? It's going to be the log of,
Log of wait, 560 over 35.
that's so true. And what is going to be the base? The same base, huh? The same base too. Okay. What is the result, guys? Somebody please divide 560 divided by 35.
16.
16. Then becomes the log of 16
True.
with the base 2. What is the result of log 16 base 2? Essentially, what do I mean is this. I'm asking you, please, to figure this out. What is log 16 with base 2 equals to what?
4?
Huh?
No, wait. It's not correct.
What was your answer?
I think it's 4, but no.
Let's see. I put the brackets there. Guys, always, we explained that yesterday also. Whenever you get the same problem, whenever you have the same problem, you do not know what is that, make a square bracket like this, put inside a question mark. You remember the rule which I explained to you, that you want to get inside a Lamborghini to drive a Lamborghini, but you end up to go to the back seat, to the passenger seat. It means that you start with the number 2. Everyone sees this?
Yep.
You just start from the back seat, passenger seat, which is 2. Then you go to the back seat of the car, and the back seat becomes here. Huh?
Mm-hmm.
Then from here, you end up to go to the driver's seat where you wanted to end with, which is 16. Huh?
Mm-hmm.
And the question is that 2 has to come to what power to give you 16?
It's 4. I'm right.
You're right. Everyone is okay now with it?
Yes.
You see this is going to be 4 because 2 to the power of 4 becomes 16? Yes?
Yeah.
Nice. Then the end result is going to be 4. And guys, you see that when you start from something like this, log of 3 logs, which they are, oh my God, it's so confusing working with the logs, isn't that?
Mm-hmm.
It's so confusing to work with the logs because they do not give you the explicit answers. And it makes so confusing to work with them. But you see, by using those 6 properties which you learned yesterday, you can simplify them to get to one explicit number, which is 4. You see this, guys?
Yeah.
Yeah?
Yep.
Nice. Any questions?
No.
No?
No.
Great. Anyone else? Ninja, Oliver, Sean?
No questions.
No questions? Good. Okay, I'm going to give you 2 examples that you work on yourself. Then we do that together. The first one is this. I'm going to ask you what is the result of if I say 2 log of x minus 1 over 2 the log of y plus log 3 times log z. That's the first example. You please do that. The other one is this. The other one is going to be the log of, use a different color, x squared minus y squared minus log of x plus y, and goes all the way inside with the 1 over 2 before. Everyone sees these notes?
Yes.
Yeah? Great. Guys, please now take your time for a couple of minutes. Try to figure this out yourself, like the thing which I did before. On the previous example, it was so similar to this. I used those 6 properties which we learned yesterday. Try to use it and try to crunch these expressions as much as you can to see how you can make them to look more compact. Okay?
Yeah.
Everyone is fine? You know what to do?
Ooh.
I
Oh
put
my
this
God.
exercise A. I put this exercise B. Yes, please go on. If you have any questions, please let me know. What time is it, guys?
9:48.
Ah, who's done, guys?
That's a little bit too fast. I'm not done yet.
It's a little bit what?
That's, it's okay.
Samantha, what you said is 2-bit what?
No, it's okay. It's okay. It's okay.
Mingje?
I'm not done yet.
Sean, are you working on it?
Yes, I finished.
Oh, nice. Or you're working on your thing of Friday, huh? The music.
Gosh.
How about you, Oliver? Are you working on it? Oliver? Linda?
Yes.
You're working on it?
Yes, but I
Awesome.
not finish.
Great, great. Continue. Thank you, Linda.
Okay.
Okay. Everyone is done with question A?
I stuck in a spot, so please go on.
Yeah. Let's do that together all, huh?
Yeah.
Let's do that one by one together. Okay. Now, should I write in front of it or change the paper? Maybe not enough space. Probably, let's do on a new paper. Okay, what is the function? The function was log of x minus log of y plus log of z. However, I had these two ones there, 2 times 1 over 2 and 3. Okay. Now, let me see your properties from yesterday. Okay. Checking your notes from yesterday. Guys, before I just continue, I just want to remind you on the notes which we had yesterday. You remember from yesterday, we said that if I should say, your main driver is wearing a hat as an exponent, it falls behind the log. Do you remember that?
Mm-hmm.
This property? I'm going to use that property right now. What it becomes now, if I just want to use property, it becomes essential like what? It becomes, I have my log of x, and now it can have his hat back. What do I mean? I can have the 2. You see that? I can bring it back. Give the hat back to the driver, becomes x to the power 2. The same thing like that. I have the log y. I can just take this 1 over 2, give the power back. Becomes what? Becomes 1 over 2 plus log z. And you see it becomes 3 because I can take the power again, give it back to the same function. So far, so good, guys.
Yeah.
Yeah?
No question.
Okay. And now, the thing which I'm going to do is this. I'm going to look at this one. There are many options you can do. There are many ways you can just solve this one. But at this stage, you're going to see this y. I'm just going to do this. But at this moment, just bear with me. What is the next step I'm going to take? Either you can just use property number 6 to use these two. But if you use property number 6 right away, you end up with what?
And end up
These
with,
two are subtracted. Oh, sorry, someone said something?
no, it's okay, just keep going, sorry.
Yeah. If I use property number 6, let me show you property number 6. You see property number 6, two functions, when they are subtracted, each one a log, we can add them back in one single log, provided that we divide them. You see that? And keep the same base. I'm going to do the same thing. I take these two functions and it becomes property number what?
Number 6.
becomes property number 6. And with this property number 6, I'm going to do what? I'm going to say, then I'm just going to write it as a log of the numerator is always what? The first function. The denominator is y 1 over 2. Correct? Is it clear for everyone?
Yes.
100% sure that you're fine?
Yes, but question.
Yeah, sure.
So basically what you're doing is you doing it like first part first, but the thing is they should do in the same time. So what I mean is actually the denominator should be y 1 over power to the power 2 plus 2 to the power 3.
Oh, you mean Z?
Yes.
Oh, no, Samantha. Look at that because look at this one like that. Look, I'm just going to throw some parentheses, big parentheses, that it shows that these two terms, I take them together. And as a result, I said this is going to be plus log of Z to the power
Oh, that
3. Huh? Does it make sense?
Yeah.
You cannot just say, okay, I'm going to put also Z this one because you just start 2 terms by 2 terms.
Oh, okay.
You cannot bring it inside because it has a log. Always remember, have you, for example, let me tell you, do you love lobsters?
Yes.
Yeah? Can you eat the lobsters without peeling off the I should say the crust on top of it?
No.
No, log is like that. You have to always, the logs is like that. It avoids being contacted. You know, it's like the lobsters. You have to get rid of them. Then you cannot take Z3 without removing its log into the denominator of this.
Mm-hmm.
Look at the log normally when you just want to do the algebra as a lobster. You cannot eat them without peeling off the main, I should say, crust which they have on top. Then so far so good, guys.
Yeah.
Any questions? Linda, Oliver, Mingjing?
No question.
No questions. Glad. Linda, how about you?
No question.
Are you fine?
Yes.
How about you, Oliver?
I'm okay.
Super. How about you, Sean?
Yes.
Super. Okay, now at this stage, guys, look at that. I have 2 logs. The first log and the second log. What is, I should say, and there is a plus sign in between. You see that? Look at the quote property number 5, which we had yesterday. We said that if there is a plus sign between 2 log functions, you can merge them, combine them into 1 log, provided we multiply the arguments of each. F of x, g of x, they are multiplied. You remember that from yesterday? Yeah? And now I see the same thing. I have 2 logs. Then I know that I can merge them into 1 simple log, write it as a log, but I'm going to multiply them together, the main arguments, which it means that I have the first argument. What is the first argument? X squared. I have y 1 over 2. And if I multiply the second argument, what is that? This is z to the power 3. Am I right?
Yes.
If I multiply z over 3 to the first argument, it can come here, z to the power 3, this one. Am I right? Which property did I use? Property number? Which number, guys?
Number 4? I forgot.
5.
5. Yeah.
You have to work a lot with these properties to remember which one is which. And essentially, we are done. Right? Any questions, guys?
No.
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 Linda,
No.
any questions?
No.
Oliver,
No.
Yingzhe,
No question.
superb. Sean,
Nope.
fantastic. Okay. Now this is the first one. Samantha, are you okay with that?
Yeah. I'm just really quick go to the washroom. I'll be back in 1 minute.
Yeah, sure. What time is it now? Maybe we can go for the break.
10:03.
Oh, that's the right time for the break, guys. Guys, let's take a break. Yeah?
Yeah.
Fantastic. Guys, please be back here by 10:18.
Okay.
Cool?
Cool.
Enjoy your break, guys. See you back then. Hello, guys.
Hello.
Everyone's back from the break?
Yes.
Great. How was it, guys? Refreshing?
Yes.
What do you do? Just when you're at home for the break, what do you do?
During this break?
Yeah,
Mm.
you are not at the school. You do not meet the others. It's like staying at home again.
Yeah, I'm just watching some videos.
Yeah, I miss the school. I like to go back to school. It's better than staying at home.
Same.
Okay, guys, let's finish the last one. I'm gonna finish this one here. Then no, let's do that. Then we just go to the new topic, which is gonna be the change of the base of the logarithms. This one was log of x squared minus y squared minus log of x plus y, correct? Then we had all of them 1 over 2. Oh no, not this one. Okay, this one is going to be very easy. If you have followed all the things which we have done so far, it's going to be very easy. Everybody's back now. Please say your names if you are there. Everyone
Samantha.
says your name. Say that again.
Samantha.
Oliver.
Minji.
Okay, thanks. Sean, are you there? Not yet. Okay, guys, this one is going to be very easy because when you look at that, don't look at that, I should say 1 over 2 before. When you look at these two functions, which property you think that is going to be most relevant to this? Property number 5 or 6?
Property number 5.
Property number
6.
6. Yes, because the whole expression inside this function is telling you that if you have two logs that they are subtracted, you can convert them into only one log, correct? Provided that you have what? You have these two functions being divided. It means that the numerator is going to be which function, guys? Say it. The numerator of the combined log.
Is y squared. The numerator is x squared, sorry.
Just x squared?
Yeah. And denominator is y squared.
No, guys, look at that. This one term.
Okay, yes, I get it. It's x minus x squared minus y squared.
That's
It's
right. Guys, look at that. It's gonna be two terms. I have one term here. I call that term 1. And I have term 2. Each one is gonna be one log.
Mm-hmm.
You do not look at only one log, say x squared, then minus x is y squared, then becomes. No, you have to look at the logs of each. Do not look inside the log function itself. Look at two ones that they are subtracted. And the subtraction is this. You see that?
Yes.
Then as a result, then I'm going to combine term 1 with term 2. I write one log. What is going to be the numerator of the first one?
X squared minus y squared.
Is it correct, everyone? X squared minus y squared. Linda?
Yes.
Is it correct?
Yes.
Mingje and Oliver, is it correct? X squared minus y squared.
X squared minus y squared over x plus y.
That's so true. Yes, Oliver. He's not back yet. Anyhow, then as everybody said, this one is going to be x squared minus y squared. And the second term, let me show that to you. Look at this one, property number 6. The second term, the g of x, which is subtracted, you see, Linda, you see, Samantha, subtraction between two logs. It becomes at the denominator. It becomes x plus 1.
Y.
Correct?
Yeah. Yeah.
And also remember that before that, we had what? We had 1 over 2. So far this. But, guys, what can I do further?
Factoring the it's just like x squared minus y squared equals x plus y multiplied by x minus y.
That's so true. Everyone agrees on it? Yes, guys. Then I can essentially write this one here like that. I say x, oh, it's dying. X minus y times x plus y, x plus y, correct? Because you can factor x squared minus y squared to this term. Is it clear for everyone?
Yes.
Say yes.
Yes.
Yep.
Awesome. Awesome, awesome. And now, okay, then what's going to happen next? It's going to be
x plus y and x plus y.
That's so true. I can take these ones out. X plus 1, x plus 1s, they are going to be canceled out. Is it correct?
Yeah.
Then I'm left with log of what?
X minus y.
X minus y. Still, I have 1 over 2 back. Correct?
Yeah.
Now, as a master step, guys, what else can I do? Can I take 1 over 2, which is going to be this one, guys, which is going to be the hat, which is behind the log function, bring it all the way as an exponent for x minus 1. Can I do that? X minus 1, correct?
Yeah. To the power to 1 over 2.
That's so true. Power 1 over 2. And power 1 over 2, what is that going to be? Isn't like that the square root?
Yeah. X minus y.
Right, and now we are done.
Okay.
Any questions, guys? How beautiful is that? Isn't that? Any questions, guys?
Nope.
No, everyone's fine?
At least I think I am fine.
Linda, how about you?
No question.
Mingje,
I'm fine.
thanks. Oliver. Oliver is not yet back.
Yes.
Oh, you're there. Are you fine?
Yes, good.
No questions?
No.
Makes total sense?
Yes.
Fantastic. Guys, please make sure that essentially that one was the very last example which we had to cover in the class for using the properties of the integral functions to simplify the terms. So far, yesterday, we were able to move from the left side to the right side to simplify. Today, we did something reverse. We had these ones expanded, we just moved backwards. You see, you can just use these, I should say, properties, either from moving from left to right or from right to left. That's what we did so far. Everyone's fine? Okay. And now, what I'm going to do is that we are going to cover something very extraordinarily interesting. And that thing is going to be the change of the base. We are going to use that a lot when we are just going to work by, let's say, Friday, when we are going to work with the logarithmic functions, logarithmic equations, and the logarithmic inequalities.
Mm-hmm.
Let me take this one back. Okay, now. Okay, now it is going to be a new lesson, guys. Please listen to that very carefully. Okay.
Yeah.
This is going to be the topic of the day, which is going to be the change. Oh, it's dead. Let's put it back. The change of base. Guys, by the way, all of you forgot to submit one exercise which I asked you to prove one identity yesterday. What happened?
I don't know how to prove it. Is equation. It is what it is. No, I tried, and I tried to put a number in there,
Huh?
like just like b log b over x equals to x.
Okay.
So you just move x in front of this equation, gonna be bx log b.
Uh-huh.
You see what I'm
Okay.
saying? Okay, so like from there, I just say when b equals 1, and the whole function gonna be equals to x. But I don't know, like, how can you do it another way?
Okay, no worries. We are going to do that in the class one day, hopefully
Yeah, it
by
is what it is.
late day, Friday. Okay, now let's talk about the change of the base. I'm just going to give you a formula, and I'm going to also prove that to you by your help then. We're going to say that, guys, so far, when we talked about the logarithms, we saw that it's going to be a kind of a functions of an exponential functions. We said that the log, let's say we take the base as b, and we take this one as x, correct?
Mm-hmm.
We said that the log of x, what is the base? The base is b, huh?
Yeah.
Then now you say that, no, I don't want to just work with the base b. We will see that very soon, that why do we need to sometimes to change the base? Because so far, whatever we did, guys, was that we just essentially worked with the same base. We didn't have to change the base. We didn't even work with it. We didn't care how much is the base. That's correct. We normally was caring about the main driver of the logarithmic functions, correct? We even didn't look at the base normally. We take it as it is. But sometimes you will see that today and also tomorrow, that you have to also come to manipulate the base in order to solve an equation or an inequality. Then sometimes you have to just work with the base, and the base becomes more important than the main driver of the function. Okay? Then saying so, the thing which we are going to do is that we are going to come to say, okay, we are going to say this formula and we are going to prove this. We are just going to work with that a lot. When I'm going to say is that I'm going to say this as equals to, I'm going to write it as a ratio of two logs. The first log and the second log. You see, my plan is that to change the base from b to, what do you want it to be, guys? For example, I have the base b. For my application, for example, I need to change the base from b to a. For example, maybe it's the base is 10, which normally we just read the logarit functions when the base is expressed by 10. But sometimes you want to just change the base to the natural number, by, for example, e. Change the base to something else. I just say, for sake of, I should say, convenience of the formula, I say that we change the base to a. Then as a result, in the ratio of these two logarithms, I just put the base a here, and I also follow the same base on top. Correct?
Correct.
Huh? Then what happens to the x and b itself? The main arguments and the old base. I'm going to take the x coming to the numerator, which forms the main function, the main driver of the functions at the numerator, and I take the b to come to be the main driver of this function. You see what happened?
Yes.
Then you see that the base of the old function becomes the main driver of the new functions when you change the base. And the base a can be anything, but it should not be 1 and it should not be 0. That's the formula, which we call that as a base of the change. We're going to use that a lot in future when we just work with the logarithmic equations and inequalities. Correct?
Correct.
Awesome. Okay, I'm just going to prove that to you. We said that as we're going to make some proof, and maybe, what time is it now? I hope that we should have enough time.
10:36.
Okay, I think we should have enough time to prove it, because I'm going to prove one, then you see how the proof works, then you can just maybe use that for the questions which you had for yesterday.
Mm-hmm.
Guys, the thing is that we always, I'm just going to write this as a proof. Bring it here. Let me use a different color. I'm going to exclude this from the top, and I'm just going to write the proof below. Guys, before we said that when we have, for example, we always try to work with the exponential terms. We said that the log starts from the left. What is the left side of this equation, guys? Where is the left? The left is log of what?
XB.
That's the log of x over b.
B.
Correct?
Yeah.
That's the left. I'm trying to just start from the left and work. I find myself to the right side. I say, wow, then the proof is done. That's going to be the strategy, guys. Starting from the left, moving towards the right. Then I say, oh, I just got the same expression. Then I proved it. That's going to be the strategy. Okay.
Mm-hmm.
I just start from the left. The left side, I know that the initial function, which I'm given, for example, I work in science, the original function which I'm given to work with is expressed as log x over b. X can be any function, any continuous function. And I have the b, which is, let's say, the base of my function. What I'm going to do, the thing which I'm going to do is this. I say, okay, I start from this, and I call this to be equal to what? I call this, it's going to be equal to, let's say, any number. I call this m. Because it's going to be my function. Correct? Correct, guys?
Yep.
Yeah.
But also, I'm going to go back to the notes from yesterday. You always learn, guys, that the logarithmic function can be written as an exponential term. Yes?
Yeah.
What we saw, you start from the back, the passenger seat, go to the back seat, then you end up to the driver's seat. B to the power g of x becomes f of x. You remember it from yesterday, huh? Yes?
Mm-hmm.
And it means that the thing which I can do with this term is that I'm going to come here and say, okay, then in terms of the exponent terms, I'm going to write, it becomes b from the passenger seat. I'm going to the m.
Mm-hmm.
Becomes equals to what? X. Correct? Correct, guys?
Yes.
Nice. And now, yesterday, and now I'm just gonna start working on this term. And I say this term, oh, this one is also dead. Let me use a different color. This part becomes my favorite function now to continue working with it. I'm gonna start from this. Okay, guys, you saw that yesterday. Also, we did something like that yesterday. We said that when we have an equality, that's right, we can take the log. We look at the log function as an operator and take the log from both sides. Can I do that? Yes? It means that if I have b to the power m, correct me, Jay? When it is equal to x, which is essentially the same thing. We saw that also yesterday in the proof that how to get from the exponential functions to the logarithmic function. We saw that we can take the log from both sides. I say, okay, I give a log to the left. I give a Lamborghini to the driver on the left. And I also give a Lamborghini to the driver on the right. Correct? Okay. And now, guys, that's the place, that's where you make a big difference. How you make a big difference? By choosing the base of your function. Because now when you give the Lamborghini, you have the choice to give the color, huh? And now that's how we choose the color of the Lamborghini, by giving it a kind of a base. And the base which I'm going to use the base which I'm looking for, A. Huh? Then I say, okay, it's going to be, if I give the base A, and this one gives the base A. Everyone sees that?
Yep.
Yes? Everyone's clear?
Yes.
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 Then so far, what did I do in terms of the exponential form of the main function which I had? I wrote it in the logarithm forms, but I give a different base which I needed, because I knew I can take the logarithm function from both sides of the equality, and it still remains the equality, correct? But the clever thing which I did, the smart thing which I did, was that to change the base there. The base initially was B, I give the base to the A, correct? And now what's gonna happen, guys? As a next step, the next step is gonna be this. What I'm gonna do, I take the hat off from, because look at that, the main driver is wearing a hat, correct?
Yeah.
And the hat is gonna fall off. Then that's what I'm gonna do. I'm gonna take the hat off. I take the m dot log of b. The base is a equals to the log of what? The main function which I had before, x, and the base is still a, correct? Okay. And now, what's going to happen next? Guys, what do you think from here? Guys, check, compare this one with the formula up there. Compare this last expression, guys. Let me highlight this here with a different color. Guys, oh, that's a new color. I never used that before. That's the silver one. Oh, very good. Guys, please compare this. Everyone sees this? Please look at this one and compare to these main functions which we had. How to get from here to there? Isn't like that? If you compare this one, this form with this one, it seems that if I divide both sides by the log b over a, I have the right side of this function. Correct?
Correct.
Then it means that if I divide both sides by this, what remains from the left side? it remains m, correct? It's equals to it's going to be the log of x base a.
Over log.
That's right. Everyone sees this if I write it here?
Yeah.
Over the log of b
Over a.
with the base a, correct? Because I divided from this one, which is inside this squared, I should say square, I divide both sides to the log of b with the base a, and I end up this. And on the right, I only with the m, correct? Any questions, guys, so far? Please, at this stage, ask me the questions because this is a very important step.
Yeah.
Guys, any questions? Linda, Samantha, Mingjing, Sean, Oliver,
No questions.
everyone is fine?
Yeah.
Awesome. Then, guys, look at that. What was the m? What is the m?
Is log x over b.
That's so true. Log m is the log of x over b. And now you proved it. Do you understand what happened? I substitute m. What is m? M is what?
Log x over b.
Log x x over b. I got it from there. You see how where did I define m? You see that, guys? Yeah? Then as a result, if I put the m there, it becomes what? Equals to this one, which is essentially becomes the log of my x with the base a over the log of b with the base a. And now I'm done. You see how did I prove it, guys?
Yes.
Super.
Yeah? Nice. Superb, Sean. Super.
Yes, that's so super.
That's right.
Oh my god.
You look confused, Samantha. You sound confused.
Oh.
I'm so dead.
Oh, I'm sorry to hear that. Why? Because of this proof?
The proof, the thing, the process, I get it. It doesn't seem sort of problem, but when I use it, I'm not sure I can really recognize. Like,
You have to reproduce it. When the class is done, please make sure that you reproduce it. I mean, you do the same thing with yours on a paper for yourself.
okay.
Yeah?
Yeah.
That's how you learn. That's how I learned it. I repeated that maybe 10 times on the paper myself. Guys, any questions? Oliver,
No.
Linda,
No.
Sean,
Oop.
Mingjay,
No question.
and Samantha.
No problem.
Awesome. Guys, then look at this one. We're going to use that extensively in future. How to change the base of a logarithm. This is going to be very crucial. And now you have also the proof of how to change the base of a logarithmic function. Huh? Okay. Now, we just have this one. We move on to do one exercise. And what time is it now, guys? Almost we are reaching to the end. Okay. I'm giving you one exercise. Call that example. Okay. Guys, look at this. For the first example, I'm going to just write log of, yes, some number, 95, which the base is set as 5. Can you please, guys, do that yourself first to convert the base into 10? Because the base, how much is the base now?
It's 5.
Base is 5. Write an expression which changes this one to the base 10, which you're always more comfortable with it to work with it. Okay, let me do that also. You see, when you want to change the base, it becomes a ratio always, like this, the formula which we had. What do I mean? It changes to 2 logarithms now. Previously, you had 1 logarithm function, and now you are having 2.
Wait, I think I got it.
I'm so glad.
Just hold on 1 second. I'm sorry. Just for
Sure,
1
sure,
second.
sure.
Tell me if I'm wrong. The answer is log 1990 over 10.
95, you mean, huh?
No, it's minus.
Oh, let me do that because I do not know the answer. Let me
Okay.
give me 1 second to do that. Okay, you said log 90 over log 10, huh? Okay, let's see. Okay, I get 2 logs because based on this formula, I see that whenever I want to change the base, I have 2 logs. Then I write 2 logs, and the base of these 2 logs is going to be the base which I desire it. The base which I look for is going to be base what? Guys, what base I'm looking for?
It's 90. The under one is wait, just 1 second.
No, I mean the base. What is the base which I'm interested to change the formula?
It's
Natural log.
That's, no, not natural log. It's base 10.
It's 10.
We talk about natural log tomorrow.
Okay.
That's right. And we just put it 10 there. Oh, not 10 there. I mean 10 there. 10 there means different.
Tinder.
Tender. I'm hungry. I'm just looking at the fried chicken thing. You said you just said tender.
That's right. I said I put the 10 there. No, I mean there.
Yeah.
Okay. And now, what happens there? The next step is going to be I take the main driver to the next function,
Okay.
and I put 5
Under.
there in the main driver of the other function.
Yeah, and then you use log like 1095 minus 10 log 105.
Oh, you mean the property number 6?
Yes.
You mean this one?
You just like because it's divided, so you use the the factor minus the
Samantha, that's so
denominator.
true. But look at property number 6. When we do that, we have a log of 2 functions, which those 2 functions are divided in front of 1 log. But look at this one. Now I have 2 logs divided.
Oh, okay.
And when 2 logs are divided, I cannot use property number 6. It's so confusing. When I was at the high school, it took me, oh my God, so much time to find the difference. It took me, honestly, so much time to find the difference. But the good thing is that now at this stage, we know that we cannot use property number 5 because we have 2 logs divided, not 1 log with 2 terms divided. Then essentially, in practice, we can I should say change the base, and instead of using log of 95 over 5, we can just use this log. Huh?
Mm-hmm.
That's right.
Oh, that's the final number?
That's right. That's we are okay with that. Then we can put the calculator to find what is this.
Oh boy.
But you can, if you want, you can change it further, but it doesn't make any difference. You can say, I'm going to write it here. You can say the log of 5 over 10. You can write it as a log of 10 divided by 2. I'm going to do that, Samantha, in order to show the difference, that why I can use this property number 6 here, but not there. You see what happened there? I have the log, and the main function is divided by 2 functions, 10 and 2. It means that I can write it as log of 10, the base 10, minus the log of 2 with the base 10. You see that, Samantha, everyone?
Yes.
And now, property number 2. What guys, what time is it now?
It's 4 minutes left.
1 minute. Look at that. Property number 2, the base and the main driver was the same. Then it becomes to 1. Then it becomes what?
1.
Becomes 1 minus log of 2 over 10. You can put it that way on the denominator in case. It's not necessary, but in case to show how property number 6 here works, I just give that to you then.
Okay.
Yes, guys, did you see how to change the base?
Yep.
Oh, wasn't that nice?
Yes. I did.
Awesome. Guys, any questions?
No.
No?
Nope.
Everyone, Linda.
No question.
Awesome. Oliver.
Yes, I'm okay.
Awesome. Mingji.
No questions.
Sean.
Nope.
Awesome. Guys, you're going to see the link tonight on the YouTube. I send the link to you of the lectures today. The second thing is that you're going to get the homework before let's say 3 p.m. then. Make sure that you submit that on time then. Okay.
Okay.
I see you guys tomorrow.
See you.
Have a nice day, everyone.
You too. Bye bye.
Thank
you.
Nice day.
Bye. See
Samantha,
you.
thanks, Mingji. Thanks, Oliver, Linda, and Arya. You're there? Arya
Me. Hey.
and Brian. Hi, Brian. David, what time did you join?
About 9:30.
9:30. Oh, I didn't
Yeah.
see you because you were not on time. I thought that you're absent today. Okay. Arya, you're still there? Arya? David? Brian?
Yeah.
Guys, please check if you were late. I'm gonna post the lectures on YouTube. I'm gonna send the link to everyone. Okay, watch that before tomorrow then.
Okay.
Okay, thank you.
See
Sorry,
you
I didn't see. I
tomorrow.
thought that you were absent today. Thanks, guys. See you tomorrow. Thanks, Brian. See you tomorrow.
See you.
Take care. Bye.
Bye.
Bye, Arya.